This is the solution to quiz 10. Okay, so we're given a story about a tool rental. So we know that we have 2 points. So we have points, say, T and C. That's to say, time and cost. The 2 points that we have is that for 4 hours, the cost is $16.06. And we also know that for 9 hours, the cost is $31.76. So it says find a linear equation for the cost y. Okay, so we've got to change that to x and y. So the two, so x is the number of hours, 4 and 9, and y is the cost, 16.06 and 31.76. Okay, so to find the slope, delta x, the change in x is 9 minus 4, which is 5. Delta y is 31.76 minus 16.06, so that's 15.70. The slope m is 15.70 divided by 5, delta y over delta x, which is 3.14, which was a little joke because 3.14 is the first several digits of pi. So the point slope formula is y minus y1 is m x minus x1. So y minus 16.06 is m x minus 4. So y minus y1 is 3.14x, and then minus, that'd be what, 12, 40, 52? And then add 16.06 to both sides. So that should be 56. That's 1256. And then add to both sides 16.06, so plus 28.62. No, that can't be right. Because for 0 hours it's $28. No. So add, so that's negative 12.6. So negative 12.56 plus 16.06 plus 350. So we can check that real quick. If we plug in 4, 3.14 times 4 plus 3.50 is 16.06. Okay, good. So this is the linear model. B, the cost per hour, well, that's the slope. Slope, just the coefficient. So it's $3.14 per hour. C, what is the flat fee? That is to say the cost even if you rented it for 0 hours, well, that's $3.50. And what is the cost of renting the tool for 2 hours? That is to say, find y when x is 2. So if we plug in 2, we get $9.78. Okay, question 2. Express the following quadratic in standard form. Okay, so then recall that the vertex formula is h is negative b over 2a. So on this specific exercise, that'd be negative 20 over 2 times 2. The negatives cancel, so that's 20 over 4, which is 5. And then k will be f at the horizontal coordinate of the vertex. So f of 5. Plug that into the calculator. 2 times 5 squared minus 20 times 5 plus 33 is negative 17. Just double check. 2 times 5 squared minus 20 times 5 plus 33, negative 17. Okay, therefore the answer is f of x is x minus h squared and then minus 17, like that. And then a is this value. So 2. So now express this standard form quadratic in that form. Well, that just means multiply it out. So that's 5 times x squared minus 6x plus 9 plus 7. So 5x squared minus 30x plus 45 plus 7. 5x squared minus 30x plus 52. Okay, last question. Suppose that we have 300 meters of fence to do this. Okay. So if we call this measurement x, then this measurement is another x. And if we call this one y, then there's 2 more y's. So we've given names to each one of those extents. So what we know is the following. What we know is that the area, well, that's A, is equal to xy. And we also know the length of all the fence. Well, we know that L is going to be 2 x's plus 3 y's. And furthermore, we know that L is 300. So that's what's known. And what we want to do is we want to maximize A. So in order for us to do that, we need to convert A to a quadratic, which is to say we need to eliminate y. So we can do that with the length constraint. We know that 2x plus 3y is 300. So, solving for y, we get 3y is 300 minus 2x, so that y is 100 minus 2/3 x. So we can plug this in there. So we know that a is x multiplied by 100 minus 2/3 x. So that would be a is negative 2/3 x squared, and then plus 100 x. So that's a quadratic, and because it has a negative leading coefficient, that means it opens down. So the quadratic opens down, and that's good, because that means that this quadratic has a maximum at its vertex. So what we want is we want to find the coordinates of that vertex. Well, the vertex formula is h is negative b over 2 little a, and on this specific quadratic, that is negative 100 over 2 times negative 2/3. The negatives cancel, and then we have 4 over 3, so that would be 100 multiplied by 3 over 4, which is 75. So that means that h is 75. K is what you get when you plug in 75, so that'd be a of h, which is to say a of 75. So if we plug in 75, that would be negative 2/3 times 75 squared plus 100 times 75. So that is 3,750. So that is the x coordinate. That is the x dimension when the area is maximized. This is the maximum area. So area is maximized when x is 75, a is 3,750, but we also need to figure out what y is, and we can figure that out here. So y is plugging that in. For that y. 2/3 times 75 is, well, 75 over 3 is 25 times 2 is 50. 100 minus 50 is 50.